Hello, I'm Miles Tails per hour. We will now move on to part 3. Now we are ready for the numericals. Let's begin from the easier ones. First question, convert 120 degrees into radians. The answer is 2.09 radians. You might need to divide it by 57.3 degrees, referring to 1 radian. Second question, convert 3 revolutions per second into radians per second. The answer is 18.85 radians per second. You can directly multiply by 2 pi. Third question, this is in terms of RPM. Convert 800 revolutions per minute into radians per second. The answer is 83.78 radians per second. First you have to divide by 60 seconds, and then multiply by 2 pi. To give it a direct conversion, multiply by pi over 30. 83.78 radians per second can also mean 5026 radians per minute. Now, it'll be harder in the next question. Fourth question, determine the angular acceleration from 4 to 8 radians per second in 2 seconds. The answer is 2 radians per second squared, like the ones you did in linear acceleration. Fifth question, what is the angle swept in a pendulum clock if the angular acceleration is due to Earth's gravity, and its time taken is 1 second? The answer is 4.9 radians, since the initial velocity is at rest. Sixth question, calculate the torque obtained when a radius vector is 0.3 meters, force vector be 10 newtons and its angle is 30 degrees. The answer is 1.5 newton meter, since sine of 30 degrees is 0.5 value. And seventh question, this is a bit harder. For the conservation of angular momentum of 30 kilograms square meter per second, given that its mass of girl is 48 kilograms, her radius of hand is 1 meter and its angular velocity is 0.625 radians per second. What will be the angular velocity if the radius reduces to 0.4 meters? The answer is 3.91 radians per second. That means its radius reduced to 0.4 meters. Now, stay tuned for the next part, telling you centrifugal and centripetal force, and Coriolis force. Like, comment, and subscribe now.